Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students who are working on the year-end summative. From the practice questions, it's question number 4. The question says, a ball is thrown in the air, tracked, so that both its height is measured and the distance horizontally traveled is measured. The function, so here's the function equation, models the height of the ball compared to the horizontal distance it has traveled. Both are in meters. And then there's a number of questions I have to answer. So first I want to really look at this equation and make sure I clearly understand what I have. So essentially we have a quadratic, I can tell that because it's a squared function, and also it's projectile motion, that's quadratic. Oh, and also this is the quadratic summative, so, big hint. But, so it's thrown in the air and it travels horizontally as it's thrown in the air. So on this axis, we're going to measure the height of the object, so how high does it get? And then on this, we're going to measure the distance horizontally it's traveled, so how far does it get? So we quite often do time versus height, but this is distance versus height. So here, D represents the horizontal distance it's traveled, and of course, H at D is the height based on that distance. So what else do I know? Well, when I look at this equation, obviously I said I already know it's quadratic. This is, however, a quadratic in vertex form. So we know that vertex form means that any question about the vertex, meaning any question that asks me for maximums or minimums, is the easiest question to answer. So let's actually look at what the specific questions are we have to answer based on this equation. So I've grouped A and B together because they're both questions about maximum. A says, what is the maximum height reached by the ball? And B says, how far horizontally has the ball traveled when it reaches the maximum? So they're both asking me about the maximum. One is about the maximum height, and one is about the horizontal travel, which is D for the maximum. So they're both about the maximum, so both of them are asking me to look at what's the vertex. When I find the vertex, I'll find a point. Now, normally that point would be X, Y, but obviously there's no X and Y here, so it's D and H. So when I find the vertex, I'll have the distance horizontally traveled and the maximum height. So all I have to do is remember, if I have the vertex form of quadratic, like what this is, how do I find the vertex? So just in case you need that little reminding, that this is what we talk about in general when we talk about the vertex form of a quadratic. And we know that when we look at it, we can instantly see that the vertex is at H, comma, K, and remembering that the polarity or positive or negative nature of K is exactly what we see, but H is always inverse to what we see. So if you see a negative for H, you write a positive, and a positive for H, you write a negative, and that's because we're looking for the value that actually makes the bracket 0. You've figured out, I'm sure, some way of remembering that yourself. So to answer both A and B, all I have to do is find the vertex, and that's hopefully really straightforward because it's in vertex form. So let's look at part C. It's not about the vertex. It says, how far horizontally has the ball traveled before it hits the ground? So when it's asking me how far horizontally has it traveled, it's saying, hey, find D. And if I'm finding D, I must know something about H. Well, it's telling me to find B when H hits the ground. Well, what is the height when an object hits the ground? Ground is literally ground level, or a height of 0. So algebraically, this question says, let H equal 0 and solve for D. So if I let H equal 0, hold on, I'm having pen issues here. If I let H equal 0, I then want to be able to solve for D. So there's the equation. Okay, something's going on. Let me fix that. So by substituting in the value of H, that's appropriate. So when it hits the ground, that's a height of 0. So I substitute the height to be 0, and now I just have to algebraically solve for D in what's left over in the equation. So that's how I'm going to solve for D. So now that I've given you the ideas behind how to find the answers to these questions, my suggestion is stop the video and actually do the math yourself. Remember, you're not learning very much if you're just watching me do the math. So now that you know how to do the question, take out your pencil and paper and actually do the math, and then restart the video and compare your solution to mine. So let's do the math. A and B, remember, we're both asking about the maximum, and the maximum means that we're finding the vertex. And when I look at this equation, it's given to me in vertex form. So there's A, and then this must be H and K. So the vertex is 20, 8. It's staring me in the face. And remember, the 8 is positive 8, so it's positive 8. And even though this might look like negative 20 to you, we take 20, not negative 20. And logically, it's because this whole bracket needs to be 0 to find the vertex. And it's actually 20 subtract 20 that makes it 0. And that's why I use 20, and that's why it always seems like we take the opposite of what you see. Anyway, that's the vertex. And again, this is D, and this is H. So the maximum height, well, the maximum height must be 8 meters at the maximum. And how far horizontally does it travel? Well, that's what this is. So it travels 20 meters before it reaches the maximum height. So you throw the ball, it travels 20 meters in this direction, but as it's moving sideways, it's also going up, and it gets to that maximum of 8 meters. And then it probably comes back down. So again, when you have an equation in vertex form and you're asked about the maximum, that's just about some of the easiest stuff we did in the whole unit. So now let's look at question C. Definitely not as simple. How far horizontally has it traveled before it hits the ground? So it's asking me to find D, and it's telling me, therefore, the height. And the height is 0 when it hits the ground. So I'm going to let H equals 0, and then I'm going to have to solve for D. So I substitute 0 in for H, and now I'm left with this equation, and here's the variable, D. It's often X, but in this case it's D, and that's what I need to solve for. So I need to isolate that variable by undoing the math that's surrounding it. And when you undo math, you do the opposite order to bedness. So in other words, I need to get rid of the thing that's furthest away mathematically from my variable. So what do I have happening to my variable? Well, I'm subtracting 20 in a bracket. That's the closest you can get. Inside that bracket is like a warm hug. Those are like best friends with D. That bracket has like a bodyguard out here that's squaring it. And that whole bracket with the square has a multiply factor. And all of that stuff together has plus 8. So the first thing I can get rid of is plus 8. And again, logically, it's because according to bedness, it was the last thing done to my variable, so it's the first thing I need to remove. And how do we remove positive 8? By subtracting 8. So on both sides of the equation, I am subtracting 8. Now on the left, that's why you now see minus 8, 0 subtract 8. Here, plus 8 minus 8, I just have nothing left over here. Now I need to get rid of, I'm sorry this is so messy, my pen is messing up. Now I need to get rid of the multiply effect of negative 0.018 times the bracket squared. So I'm going to divide on both sides by that multiply. So the multiply is negative 0.018. So on both sides I now divide by negative 0.018. So on the right, this negative 0.018 simply cancels out that one. And on the left, if I divide in my calculator, I get a decimal, so I'll round. So I get 444.44 equals. So I'm just down to the bracket squared. So I can't get in the bracket yet because I've got this squared. So now I have to get rid of square. And the opposite, the way to undo square, is to square root. And you have to square root both sides. So on the right side, the square root of something squared, well, that just cancels out. I have D minus 20. On the left, I need the square root of 444. Now, remember, when you take the square root, you actually get two different answers. You get the positive and the negative, what your calculator says. So this is 21.1. The square root of 444.44 is 21.1, but it's both positive and negative 21.1. And then finally, I'm going to be able to add 20. But I have to be careful. I have two different numbers here, so I'm going to write two different equations. Positive 21.1 equals d minus 20, and negative 21.1 equals d minus 20. And then add 20, I get 41.1. Add 20, and I get negative 1.1. So I've got two algebraic answers. The height of 0 occurs when the horizontal distance is 41.1 meters, and when the horizontal distance is negative 1.1 meters. Now that negative doesn't make much sense. The ball didn't go backwards by 1.1 meters, so this is an inadmissible answer. So my answer is that horizontal distance traveled by the ball before it hits the ground is 41.1 meters. Again, because this one, well, it just doesn't make sense to go backwards. So I hope that was helpful. And again, think about the bigger skills here. How do you do math with a vertex form? How easy it is to find the vertex, but then the sort of complicated algebra you need to find x, or in this case d, if you know h. So definitely worth practicing on that. Hope that was helpful. Happy studying.